Welcome and thank you for joining. We are preparing for the unit test on equations and word problems, grade 9 math. Let's get started with some review questions. So first, we'll solve some equations. Remember, when solving equations, we're trying to isolate an unknown variable. And to do this, we use what we call the reverse operations. What that means is that if we have a number added to the variable, then we subtract that number from both sides of the equation. If we have a number subtracted from the variable, we add that same number to both sides of the equation. If the variable is multiplied by a number, then we divide both sides of the equation by the number that is multiplying the variable. And if the variable is divided by a number, then we multiply both sides of the equation by that number. Now let's see how this works in the first 4 examples. So the left side is negative 6 times x, and the right side is negative 24. So we're trying to isolate the variable x, which is multiplied by negative 6. The reverse operation of multiplication is division. So we will divide both sides of the equation by negative 6. So then we have x on the left side equal to negative 24 over negative 6, 4. Next we have y plus 7 equals 4. So this is a case where the variable is added a number. So in order to isolate the variable from the number added to it, we subtract both 7 from both sides of the equation. Now, this is what happens behind the scenes, but you're probably aware that another shortcut to solving the equation is by taking 7 to the other side of the equation. Now, this is a practical way of describing it, but algebraically, this is what happens. So we are practically subtracting 7, which means that this becomes a 0, and on the other side, we have number 7 with opposite sign. So now the variable y would be equal to negative 3. Next we have x minus 8 equals negative 4. So theoretically speaking, what we do in this case is add number 8 to both sides of the equation. That's the reverse of subtraction, right? So in other words, we say we take number 8 to the other side, negative 8 to the other side, and we change the sign, negative 4 plus 8. That's because negative 8 plus 8 here is 0. So that means that x equals positive 4. Now, the last example is the example where the unknown variable is divided by a number. So when this happens, a over negative 8 equals 4, we perform the reverse of division, which is multiplication, which means that we are multiplying both sides of the equation by the exact same number in the denominator. So as you can see here, negative 8 and negative 8 divide to 1, and we get a all by itself equal to 4 times negative 8, which is negative 32. So let's continue with some more examples. So these are multi-step equations. We isolate the unknown variable term. So in this case, the term negative x. Now remember, whatever is in front of x, whatever is multiplying x, is going to stay with x in the first step. So first we'll isolate the term that has a variable, so the term negative x, from the other numbers added to it. Or in other words, we say we take number 12 to the other side and we change the sign of it from positive to negative. So negative x equals 14 minus 12. Simplify. And now we need to isolate x from this negative sign. Or you can also see the negative sign as a coefficient of negative 1. So divide both sides by negative 1, and we get x all by itself, and x equals negative 2. Next we have 2x plus 6 equals 4x plus 12. So in this equation, we will have to first group the terms that contain the variable. In this case, 2x and 4x. And we do this by taking the variable terms to one side and numbers on the other. Now, since I want to keep numbers on the right side, I'm going to write the number that is already on the right side. And since I want to keep variables on the left, I'm going to write the variable term that is already on the left side as is. So next, we are transferring this variable term to the other side, and we have said that transferring a term from one side to the other by addition, subtraction will switch the sign to opposite. So 4x is on the right side, is positive. So when you take it to the left side, it becomes negative. Number 6 is on the left side. We want it to go to the right side, which means that we need to change the sign of it from positive 6 to negative 6. 2x minus 4x, negative 2x. 12 minus 6 equals 6. Now we're isolating x from a number multiplying it, which means that we need to divide both sides by the number multiplying it. So that will leave x all by itself on the left side, isolated, and the right side is negative 3. So x equals negative 3. In the next example, we have 0.5, 3x minus 1.2 equals 0.5x. So first we will have to expand and simplify the left side. So 0.5 times 3x is 1.5x. And then minus 0.5 times 1.2, which equals, use a calculator for it, 0.6. And the right side has only one term, so we write the term as is. Now we have to think about grouping the x terms together and the constants together. So the terms that have an x will go to one side, depends on where you want to take the terms. I like to keep the variable terms to the left side. So I will bring 0.5x to the left, which means that 0.5x will change the sign from positive to negative. And negative 0.6, which is a number, will go to the right side, so positive 0.6. Simplify, 1.5x minus 0.5x is 1x, or simply x, equals 0.6, and that would be the answer. So next we have 2 times x plus 3 equals negative 4x minus 5. So again, we'll start off with expanding and simplifying. So we have 2 times x plus 2 times 3. The right side, same thing. We have 4 times x minus 4 times 5. So 2x plus 6 equals 4x minus 20. Now we group the variable terms to one side of the equation, which means that if the variables stay on the left, 2x is sitting wherever it was, nothing changes for it. Numbers stay on the right, negative 20 will stay as is on the right side. Now, the number positive 6 will have to be transferred to the other side, which means that it will switch the sign from positive 6 to negative 6 as it moves. The term 4x is going from the left side to the left side, which means that 4x now will become negative 4x. So 2x minus 4x equals negative 2x. Negative 20 minus 6, negative 26. Now we isolate x from a number multiplying it, which means that we're isolating it from negative 2. So divide both sides then by negative 2. So now we have x equals negative 26 over negative 2, positive 13. Now let's take a look at some more fun equations. So 6 minus, remember you have brackets here, x minus 4 equals 3x plus 70. Now remember that the number 6 in here, is not multiplying this, so it has nothing. You don't have to bring 6 in. It's a common mistake people make. The only thing that is sitting next to the brackets is this negative sign, which you can imagine it as a coefficient of negative 1. Or you can think of it this way. I have a minus in front of brackets, which means that every term that is inside the brackets will switch to opposite sign when I remove brackets. So 6, x is positive, so subtract x, and then subtract negative 4, which means add 4, equals 3x plus 70. Now, variable terms will sit on the left side of the equation, which means that negative x is already on the left side, so it stays as is, but 3x is transferred from right to left, which means that it becomes negative 3x. So that would equal 70. And we have number 4 and 6 together. So we're going to subtract 4 and 6 from the right side. Negative x minus 3x, negative 4x. And 70 minus 4 minus 6 equals 60. Now isolate x from negative 4, which is a number multiplying it, which means that we divide both sides by negative 4. Now we have x equals 60 divided by negative 4, which is equal to 15. Remember, negative. Next, 3 times x minus 4, so 3x, and 3 times 4, so 3 times x minus 3 times 4, and you don't have to show the step 3 times 4, you can multiply right away. So equals negative 2 times 2x minus 2 times 7. And then plus 16 at the end. Now remember, 16 is outside the brackets. It has nothing to do with the negative 2. So try to separate this idea, right? So these are terms, and this is the multiplication. Now, that would give us 3x minus 12 equals negative 4x minus 14 plus 16. I would simplify each side if possible, or where necessary, which means negative 14 plus 16 equals 2. So now I have variable term, constant, variable, constant. So variables to one side. Favorite side, left side. Negative 4x becomes positive 4x because we are moving it. And negative 12, since it is being transferred to the other side, becomes positive 12. So 7x equals positive 14. Now isolate x from number 7, which is multiplying it, which means that we have to divide both sides by 7. I have to write this. And we have x all by itself, isolated, and equal to 2. Now we'll take a look at an equation that involves fractions. Remember that whenever we have fractions, what we do is we multiply by the expression in the denominator. So we have negative 6 in here divided by 3x plus 4, which means that we need to eliminate the denominator first. To eliminate the denominator, and when you think about it, denominator is just an expression dividing the numerator, then we perform the opposite of division, which is multiplication. So we have negative 6 over 3x plus 4. And the other side has a 2. So we multiply both sides by 3x plus 4. If you haven't seen examples like this, nothing to worry. Try to look at the denominator, even though it has x in it. Try to look at it as a number and perform the same operation that you would have as if you had a number in the denominator, just a single constant number. Now, as you can see here, we have 3x plus 4, 3x plus 4. Negative 6 on the left side, and then the right side is 2 times 3x plus 2 times 4. So negative 6 equals 6x plus 8. Now, in this case, you see that the variable term, which is the only variable term actually in this equation, is on the right side. So instead of moving the variable to the left and this number to the right, which requires two operations. We can simply leave the variable term where it is and then bring 8 to the other side. Negative 6 minus 8, because the sign will change from positive to negative, is negative 14. Now we isolate x from the coefficient. So divide by 6, and negative 14 over 6 in more simplified terms will be negative 7 over 3. So one more equation with fractions. We have 2x plus 3 over 4 equals 2 1/4. So first, I would convert this mixed number into improper fraction. So 2x plus 3 divided by 4 equals 4 times 2 plus 1 equals 9 divided by 4. So as you can see, we have denominator of 4 on both sides. So to eliminate the denominator, we multiply by 4 both sides of the equation, and we have 2x plus 3 on the left side. Remember, 4 and 4 divide to 1 equals 9 and 4. 4 and 4 will divide again to 1, so 9 over 4 times 4 equals 9. Isolate the variable term first from the number added to it, which means that take 3 to the other side, in other words, and change the sign of it. And we have 2x equals 6. Isolate x from the number multiplying it by dividing both sides of the equation by 2. As you can see here, 2 and 2 will divide to 1. X will be isolated with a coefficient of 1, and x equals 3. So let's take a look at the next equation. Now, this is again an example of an equation with fraction. First things first, we need to find the lowest common denominator. This is my favorite way of finding the lowest common denominator. I list the denominators I have first. So the denominators I have are 4 and 6. And then I break them down into its prime factors. So you do not want to count 1 in there. Just the prime factors such as numbers 2 or 3 or 5, 7, etc., etc. So number 4 has 2 times 2 as prime factor. So it can be written as a product of the prime numbers 2 and 2. Number 6 has the prime factors 2 and 3. So since 6 has a prime factor common to 4, which is 2, so I will list it right under the same factor of 2 here. You can put it in here, doesn't really matter. So one or the other in this case. And 3. So for 3, I will assign a new spot because 3 is a factor that only 6 has, not number 4. And then I would draw a line, a longer line. And I would write down here the lowest common denominator equals, bring the number 2 down. So that would be 2. Bring the next factor down. Oopsie, here we go. Which is the number 2 down here. And lastly, bring the last factor down, which is the number 3. So 2 times 2 times 3 equals 12. So that means that the lowest common denominator is 12. So next, what we want to do is multiply every fraction or every term by the lowest common denominator. Remember, because this is the lowest common denominator or the lowest common multiple of denominators, that's a long name for it, the number 12 is the smallest number that is divisible by all the denominators in the equation, which means that if you multiply by 12 both sides of the equation, which we're allowed to as long as we do the same thing to every term, perform the same operation to every term in the equation, both sides of it, then number 12 will simplify all the denominators. Let's see how this works. So we have number 12, the lowest common denominator, multiplying x minus 1 over 4. And number 12, again, the lowest common denominator, multiplying 3x plus 2 over 6. Simplify 12 divided by 4 equals 3. So what that means is now we have number 3 multiplying x minus 1. Similarly, 12 divided by 6 equals 2. So now we have number 2 multiplying 3x plus 2. As you can see now, our equation is denominator free. So all we have to do is solve the equation just like a normal equation with no fractions in it. So 3 times x is 3x, and 3 times negative 1 is negative 3. 2 times 3x, 6x. 2 times 2, 4. 3x minus 3 equals 6x plus 4. So we can't simplify more on its side, so we're going to bring the variable terms to the left side and the numbers to the right side. So we have negative 3x on the left, 7 on the right. So divide both sides by negative 3 to isolate x. And x would be equal to, remember these two will divide to 1, right? Negative 7 over 3. Now remember that if we have a positive divided by a negative, it's the same as if you have a negative divided by a positive, and it's also the same as if you have a negative right in front of the fraction, 7 over 3. Let's take a look at another equation. So in this equation, we have 1, 2, 3 terms. Now, some of the terms are in fractional form and some are just non-fraction terms, which we can convert into fractions if we decided to do so by giving it a denominator of 1. So now we look at all the denominators. We don't want to have denominators because that makes it very hard to solve the equation. So we need to eliminate them. And the quickest and the right way to eliminate denominators in an equation is by multiplying every term in the equation by the lowest common denominator. In this case, the lowest common denominator is 2x. Now, that is the smallest or the lowest number, the smallest term that you can multiply every fraction with that is able to eliminate the denominators. So let's get to work. 2x will multiply 2 divided by x plus 2x will multiply 3 over 1 equals 2x will multiply 1 over 2x. Now remember that the operation that exists here between 2 and x is multiplication, so that will simplify the x in the denominator. So 2 times 2 is 4 plus 2x times 3, 6x. And 2x will divide 2x into 1, so the right side will have just 1. So now we have a denominator-free equation. I'll keep the variable term on the left side and bring 4 to the other. So 6x equals 1 minus 4, or 6x equals negative 3. Isolate x from number 6, which is multiplying it. So divide both sides by 6. And don't forget to reduce your answer. So negative 3 over 6 or negative 1 over 2. Next, x plus 2 over 2 equals 3x over 3 plus 5. So make every term into a fraction. Fraction, fraction, number. Give it denominator 1, becomes a fraction. Find the lowest common denominator. We need the lowest common denominator so that we can eliminate the denominators in every term. Now, when the lowest common denominators are all prime numbers, it's very easy to determine it as the product of all the prime numbers. So we have 2 times 3, which is 6. So we'll multiply by 6, x plus 2 divided by 2. We'll multiply by 6, 3x divide it by 3, and we'll multiply by 6 the number 5 over 1. Now another thing you probably notice here is that the 3 can simplify. You can do so. That may happen, not very often, but it may happen when solving equations, and it makes solving the equation a lot easier. So start simplifying. 6 and 2 will divide to 3. So we have 3 times x plus 2. 6 and 3 will divide to 2, which means that we have 2 times 3x. And 6 and 1 divide to 6, so that would be plus 30. So now expand and simplify, so we have 3x plus 6. 2 times 3x is 6x, and then plus 30. So I have one variable, one term, one variable term, one constant term. So take the variable terms to one side. Left is my favorite, and that's not a secret. Okay, 30 minus 6. So that would be negative 3x equals 30 minus 6, 24. Isolate x from negative 3, so divide both sides by negative 3, and x equals negative 8. One last example of equations. 2 times 3x minus 1 over 5 plus x plus 2 over 4 equals 4 over 1. Everything a fraction. Remember, 1, 2, 3 terms in total. Lowest common denominator. Now, because the denominators are all prime numbers and all different from each other, that means lowest common denominator is the product of them. So 5 times 2, 10. So that means we'll multiply by 10 every term in the equation. So 10 will divide 5, and it will give number 2. 10 will divide 2, and it will give number 5. And 10 divided by 1 is still 10, so we're going to leave it as is. Let's get to work. So we have 2. I'm going to follow the long way, sort of, so that we can see where all the numbers are going. And then we have the 5 that is multiplying x plus 2. Remember to keep the numerator in brackets, especially if you have more than one term in the numerator. And then 4 times 10. So we have 4 multiplying 3x minus 1 plus, you can start expanding in here, 5x plus 10, and that's 40. So 4 times 3x is 12x, 4 times negative 1, negative 4, 5x plus 10 equals 40. I will simplify each side first. So in other words, I'll try to collect like terms. So I have 12x and 5x, which can be combined to give 17x. And then we have negative 4 and positive 10, which combine to give 6. Take all the constant to the other side, leave the variable on the left. So 40 minus 6. So 17x equals 40 minus 6 equals 34. And divide both sides by 17. X equals 34 over 17, which is 2. So in the last example, the very last example, we are going to solve and perform a check on the solution. So we have 10x, first we solve, equals 4 times x plus 4 times 1. So 4x plus 4. Since the variable here is on the right and the left side, then I'm going to take variables to the left. So 4x is moving to the other side, changing the sign to negative. 10x minus 4x equals 6x equals 4. So x equals, divide both sides by 6, 4 over 6 or 2 over 3. Now, to check the solution, we build a small little t-chart. So the way this works is we write the left side in one column and the right side in the other. And we have to write the equation as is. And then we evaluate at x equals 2 over 3. So if x equals 2 over 3, then the left side will become 10 times 2 over 3. The right side will become 4 times 2 over 3 plus 1. Evaluate the left side, so that will be 10 over 1 times 1 over 3. Remember, that's how we multiply fractions. So the left side is 20 over 3. Now let's take a look at the right side. So on the right side we have 4 times 2 over 3 plus 4 times 1. 4 times 2 over 3, when you multiply, again, tops together, bottoms together, that will be 8 over 3 plus 4. So 4 has a denominator of 1. In order to combine the two fractions, we need to make denominators the same. And the lowest common denominator is 3, so we multiply 4 over 1 by 3 over 3. This will make it 8 over 3 plus 12 over 3. Keep denominator the same, 3. Numerators are added. So 8 plus 12 is 20 divided by 3. As you can see, the left side equals the right side. Therefore, the solution is correct. So x equals 2 over 3. So this was the review portion for the solving equations. And in the next video, we'll talk about how to approach solving word problems with equations. Thank you for learning with me. Bye for now.